Ladies and gentlemen, boys and girls, welcome to my little C++ mini-series where we're going to be making a maze solver. So basically, we're going to feed it one of these map files. That's a maze, and there's an exit, and our little player here is going to navigate through the maze. So it's kind of just kind of showing basic AI, kind of. But it's still a cool little project. I thought I'd make a little video on it. So first things first, we're going to be using C++ and Allegro 5. So if you don't know either of those, you might want to learn a little bit about that first. But I'm just going to jump right into it, and you can follow along. And if something is not making too much sense, then I think you'll be able to understand everything fine if you have a basic knowledge of C++, and even still, if you don't know Allegro that much, I'm going to be explaining, so I think you'll be good. So the first thing we need to do is we actually need to go grab Allegro, because I currently don't have it on this computer. So we're going to go ahead and run over to allegro.cc, and my internet's really bad today. Sorry about that. And we're going to go over here to Files, 5, and we want Visual C10. We're going to go ahead and grab that. It's going to take a little bit. So that's happening. I'm just going to... Actually, we can't really do anything. So hold on one second. Okay, so it is finally done downloading. So I'm going to open this up, and I'm going to go ahead and throw Allegro. I have a special little location I like to keep all of my my libraries. So I'm going to go ahead and throw Allegro into here. And now we can go back into Visual Studio, and we'll actually set up the project and get started. So we go to additional include directories, and we add in Allegro include, select folder, okay. Then we go to the linker, additional library directories, and we add in, where is it? The lib right there. So if you don't know what I'm doing, I'm basically just adding the includes and the library. It's pretty basic. You should know how to do this if you've used libraries before, but if not, just kind of copy what I've done. It's pretty simple. And then here we need a, what's it called? This is the part that's always kind of annoying. Right here. So we're going to go ahead and just copy the name of this, throw it in here, and put a .lib at the end. Click apply, click OK, and then actually we need to copy this, and then we'll deal with that in a minute. Okay, so go ahead and include Allegro 5 / allegro.h. We're also going to need, I think we'll need native dialog. We'll need, we won't need primitives. We'll need Allegro image though. So image, we're going to need Allegro TTF. So there we go. And finally, we'll also need Allegro font. Oops. So include Allegro 5 font. There we go. That should be good. Now let's go ahead and make our main. Go ahead and do that. Return 0, and let me build it real quick. Oh yeah, I'm also rendering a video right now, so hopefully nothing will be too slow in this, but we'll find out. Okay, so in our debug, I'm going to put the Allegro DLL there. All right, now let's actually get into the maze. So, first of all, we're going to need an enum for the all the different directions. So we have up, down, left, and right. We'll also need, I'm not sure if there's already a built-in, but I'm going to make a little vector 2D thing, basically just to hold the X and Y position. And we'll make a XY, and we'll make a constructor for it. So X position and Y position. And we'll say X is equal to X pose, Y is equal to Y pose. Okay, so there we have our vector. Now we need to make some other, these are our constants, so we're going to have our window title, and this is just going to be called maze solver. We need our screen width, and for this I'm going to do 400 by 400. So screen height is also 400. We need our FPS, and we don't want it to go too fast. If we make it 60 FPS, he'll solve the maze in like half a second. So I'm going to put it at 10 so we can actually see him walking around and solving the maze. And we'll also need a our game loop boolean to determine whether we should continue with the game loop. Now we also need some. Here I'm gonna comment this real quick. So we have our constants. We also have our Allegro stuff. So right here we need our Allegro display. We need our Allegro event queue. And this will just be event queue. We need an Allegro timer. We need we need our bitmaps. So one for the tile, one for the goal, which is basically instead of just having a hole in the wall, we're just gonna have an X, and the player needs to try to get to that. So that's the goal. You could put the X on the outside so it looks like he's leaving, but I'm just gonna have the X. So, and finally we'll need our Allegro font, and this is just gonna be called font. Now, next we're gonna need all of our map stuff. So here we're going to make, we need to include vector, and for the sake of ease of use, we're just gonna use the standard namespace. Oops. Okay, there we go. That should be good. So we're gonna make a vector of a. Oops, why am I doing that? A vector of a vector of an int. So we have pretty much a multi-dimensional array of ints. So that's going to represent the various squares, and we're going to have vector 2D, which is the map offset. So that will be for the screen scrolling. We also need a tile size. This is going to be 32, and the map width and map height, which will be determined when we load the map. Now, I don't think I mentioned this, but this maze solver is going to use the right hand rule. So we're going to need a couple of variables for this. This is going to be the player stuff, and we're going to need a vector 2D guy position, and to start it off, we'll put a -1, -1, just so we know that the guy is not loaded yet, because the map is the map file is going to tell us where his position is. So we're just going to use this default value. So if it doesn't load correctly, he'll still be -1, -1, and we'll be able to deal with that. And then we also need a right hand, because it's the right hand rule. So we're going to need a variable to keep track of which way he's going. Oops. And we'll also need his direction he's going, which is going up. And we'll also have a couple of these booleans. We might not use them, actually, but we'll see. Okay, so we have most of our variables we need. Now we're also going to have a couple, actually just two functions. We have a CheckMove and load map, which will take a constant char file. And we'll deal with those later, but right now, actually we are going to, oh, we do have native dialog box, okay. For some reason I thought we didn't include that. So we're going to do if not al init, then we're going to do al show native message box, give it a null, error, Allegro failed to initialize. This is basically al init tries to, well, init stands for initialize, so you can obviously tell that it's initializing Allegro. You have to do this at the start of all your Allegro programs. And this native message dialog box, if there's an error, it's going to put this message to the screen. And, okay, that should be good. So, we initialize Allegro, and we make sure it initialized correctly using this if statement. Now, we need to create the display. So al set new display flags, and we're going to make this windowed. So go ahead and pass Allegro windowed, and then we're also going to load our display. So display equals al create display, and we use our screen width and screen height, like so. And let's also make sure the display got made correctly. So if not display, we're going to show another message box that says Allegro failed to create the display, like so. And then last but not least, we'll set the window title. So al set window title, set the display's window title, so we give it a display. And we have our constant we made earlier, which is the window title, like so. Okay, everything looks good. Next, let's do, we're just going to set a few things real quick. Map loaded, hold on. Map loaded equals false. Map solved equals false. First move equals true. Quit game equals false. Guy position dot x equals -1. Guy position. Oops, spelled that wrong. We're basically just giving everything default values. And map dot clear. So yeah. All right. Now, next, here, let me comment this real quick. Setting default values. So after we set the default values, we also need to install Allegro components and initialize the add-ons. So we're going to need to install the keyboard. We're going to need to initialize the primitives add-on. Actually, what am I doing? No, we won't. We're not using primitives. But we will need to initialize the image add-on, and the font add-on, and the TTF add-on. So basically we're just setting everything up, and now we need to create the core Allegro components. So first of all, we need to create a timer. So al create timer, and we do 1.0 divided by FPS, which will give us the our constant frame rate. So we need to also set up the event queue. So al create event queue, and we need to register our event sources. So al register event source, event queue, al get keyboard event source. This is the one thing I don't like about Allegro, is how long everything is. Like, this takes forever to write. Also, I don't know if I'm explaining things very well, but I will go over it real quick after I finish this up. But like I said, you should have a basic knowledge of C++ if you're watching this series. And if you're confused by these Allegro things, you'll probably want to go watch some Allegro tutorials if this is over your head, but I'll try my best to explain. But okay, so I'm going to run through everything real quick. So first of all, we have our enum, which will tell us what direction we're moving. We have our vector2, which stores the an x and y position for various things. Our constants, which are our different game components, so our window title, width, height, FPS, and our game loop boolean. So as long as this quit game is false, the game will keep running. So when the player gets to the end of the level, quit game will be true and the game will quit. And then our Allegro stuff, the display is just the screen. The event queue is the thing that gets input from the user, so it could be keyboard input, mouse input, stuff like that. The timer keeps a constant FPS rate. If we didn't have a timer, the game would run faster on faster computers and slower on slower computers, but this will keep everything in a constant frame rate. And then we have all of our bitmaps and fonts, our map offset, everything else kind of straightforward. The guy's position, the goal, right hand. We initialize Allegro. We create a new display. We set all the default values, install the keyboards, the images, the fonts, the TTFs, and we create the timer and set up all the event queue. So here we make it so the event queue, we can get input from the keyboard, we can get input from the display. So that way if someone clicks the red X, it'll actually close, and we also get from the timer, which will give us the constant frame rate. Sorry if that's a little too much, or if I'm spoon feeding you. Okay, next we need to load the resources. So tile equals al load bitmap, and we'll do tile.png because that's what I named it. Player equals al load bitmap player.png. Goal equals al load bitmap goal.png. Oh, by the way, I will put a link for all these resources in the description, so that way you don't have to try to make your own. And if you want to make your own, that's fine too. But if not, it's fine. And you can go ahead and download any font you want as long as it's a TTF. So yeah. Okay, so there we go. We have everything up and running. So now we actually need to start up the game loop. So we start the Allegro timer. while not quit game. And yeah, here is our game loop. So we need to create an Allegro events, which will get the input from the event queue. So al wait for event queue, and we pass in the address of events. And then here we'll do if events dot type equals Allegro event key down, and events dot keyboard dot key code is equal to Allegro key escape. Then we're just going to quit the game, just like that. So basically, we're saying if the event is a key down event, so if they clicked a key, and if the key is Allegro key escape, which is just the escape key, then we're going to exit the game. And then we also want to check if events.type equals Allegro event display close, which basically means if they click the red X, then we also want to quit the game. And next, so that takes care of if they want to exit the game. Now let's actually make the, well, it's not really a game, but you get the point. So next we need to do if the timer ticked. So if Allegro equal, if the type is an Allegro event timer, then we're going to go ahead and in here is where we're going to do all of our checking. So when I previously did this, I needed to do if not first move, because the player would start moving before you could actually see him on the screen. So we're just going to do that, and we also need to check for the move. Now, you know, let's go ahead and actually run this and see if it'll work, but I actually need to put our resources into the game real quick. So let me go ahead and copy these, throw them in there, and also throw them in here, and we'll see if we have any errors so far, which I have a feeling we might. Let's see what happens. Oh, we need a Allegro monolith. I thought we put that in there. Oh. Probably need to put it in here too. Okay, let's run it real quick. Hold on one second. Okay, I found the problem. I included the wrong DLL. So go ahead and go in the bin and grab the monolith MD debug DLL. So back into maze solver, and we actually need to paste this one in there and this one in there, and now it should run. Okay, so as you can see, we have a little window, and if we click the X, it closes. Let's also check if click escape, that closes. Okay, so far everything's working quite well. Before I forget, though, we need to, right at the end, we need to free up all of our resources. So al destroy bitmap goal, al destroy bitmap player, and al destroy bitmap tile. So we destroy the bitmaps. We also need to destroy the font. So destroy font. Al destroy timer, and destroy the timer, and al destroy event queue. And oh yeah, last but not least, we need to destroy the actual display. So just pass in display right there, and that should be good. Now, so we check the move, which we haven't done that yet, but okay. Now we basically CheckMove will determine where the player should move next, and then right here we're actually going to move the player to the location. So if direction is equal to up, we are going to move the player up. So we need to create a temporary variable, and this is map at now this is one of the tricky parts. Or basically, if we're moving up, we're basically just swapping the two tiles of the guy and the tile that's above him, which would be an empty space. So we just swap those positions. So y minus 1 is the tile above us, and at x position is guy position dot x, like so. Make sure you spell it correctly though. Okay, now we do map at guy position dot y minus 1 dot at guy position dot x equals map at guy position dot y at guy position dot x. So this is basically just swapping. So pretty self-explanatory. This is actually going to take a while, so I think I'm going to actually just stop the video, and I will actually do it all off camera and then just show you. And also, don't forget to minus the y of the guy position. So, hold on one second. Okay, so here it is. It's all filled out now. So, it's basically the same thing. So, if the direction is up, the temporary variable is the tile above the guy, and then we're going to swap him. Here, let me kind of show you. Let me open up GIMP real quick, and I'll kind of explain a little bit better. So, basically, make a new, that should be good. Okay, so our game is, or the map is represented by a 2D array, or a 2D vector actually. And so we have all of our different X and Ys. This looks horrible. Oh, here. So basically it's just pretty much like a big square. So we have our up and down. Wow, this is a this is a horrible drawing. So okay, that should be good. Now let's imagine these red ones are blocked tiles, like so, and our guy is this green one. So we're saying after the CheckMove function, which we haven't wrote yet, determines which space we need to go. So if the space that we need to go is the one above us, the program is basically going to make a temporary variable. So this is a temporary variable right here, and we are going to, here, let's also, these golden ones are empty squares. So here's our player, and we need to go up. So what it's going to do is take the square above us, copy it to the temporary variable, then it's going to take the guy, put it to the square above us, and it's going to take the temporary variable and put it to the guy. So as you can see, we have swapped. So let me undo that real quick. So here we are. We need to move up. Temporary variable, swap it, just like so. That's basically what's happening. And, you know, it works the same way for the down, left, and right. It's just different x and y. So that's my little example for you. Hopefully that made sense. If not, go ahead and leave a comment, and if you have any questions about anything, go and leave me a comment. I know I'm not the best at explaining, but I'm trying. So next we need to draw. So we're going to clear to color and AL map RGB 000. So we're just going to make a blank black screen, and then we'll draw everything after that. So now we need to get the map offsets, which is going to be map offset dot y is equal to guy position dot x times tile size minus screen width divided by 2 minus tile size divided by 2. So, nope, that needs to be capitalized. Basically what this does is it just is going to center the screen on the player. It's probably the most basic screen scrolling you'll find. So if you don't know much about screen scrolling, there's quite a lot of resources on the internet to find out about it. Basically, it's just this determines where the screen's going to start drawing. So let me make another example real quick. So say we have this this big map. It's like this big, with our x and y's and our players here. And we have a, let me make a new layer. And this is our, so let's say our screen is only this big, so we can only display this much of the screen at a time. So this right here is basically going to get the map offset, which is the relative to the guy's position minus the screen width divided by 2. So basically, in a nutshell, it basically just determines where this screen should start drawing. So if the player's over here, the screen's going to draw like this, so this is what's going to be on the screen. If the player is, hold on. Let me get rid of that player. Let's make the players over here now, so the formula calculates that we need to draw the screen like so, just like that. That's basically what screen scrolling is. If you want to learn more in depth about that, I'm going to make some actual game development tutorials soon, so I will go over in depth all of these real quick. This is more or less just a showcase of a map solver. So now we need to get the goal position. So we're just going to draw the goal on top of the tiles. So times tile size minus map offset dot x, and make that null. So basically we just draw the goal, and then last but not least, we need to actually draw the tiles. So for this we need a double for loop. Int I equals 0, I is less than map height, I plus plus. For j equals 0, j is less than map width, and j plus plus, like so. Make sure you spell things correctly. Now, in our map file, here, let me show you. The zeros represent empty floor space. The ones represent walls. The 9 represents the player, and the 8 represents the goal. So keep that in mind. So if map ji is equal to 1, which means if the tile is a wall tile, we're going to draw the tile image at I times tile size minus map offset dot y, j times tile size minus map offset dot x, and null. So basically, when we're looping through the map, if the map is a wall, we draw a wall. So very simple. Next we do else if it is a 9. We're going to draw the player. So player, and yep, everything else is good. And outside of these for loops, we're going to, if the map is solved, print a message. So if guy position dot x is equal to goal position dot x, and guy position dot y is equal to goal position dot y, like so, we say al draw text font al map RGB. We're going to draw this text was white, and we need to draw it at the right position, so position.x times tile size minus map offset dot y, guy position dot y times tile size minus map offset dot x minus 30, because we want to draw it a little bit above the player, so not directly on top. And we need to, we're going to center it. So align, oh, sorry, you can't see this, can you? So Allegro align center, and we'll just say, I did it, yay me. Like so. So basically, if the player's position is the same as the goal's position, then we're going to draw I did it, yay me, right above him. So, and then we also need to set map solved equals true, and quit game equals true. Actually, we might need to change that, but we'll see. Next, first move equals false, and al flip display. So there's that so far. Now, one thing we need to do is actually write this CheckMove function, because this is can't really do anything unless we actually check the move. So we're going to go down here. Oops. Void CheckMove. And actually, hold on one second. Hold on. Okay, let's get right into this CheckMove. So, first of all, we need to check if the direction is up, then basically what's going on. If we are going up, the right-hand position would be right to the right of us. So we're going to check if there's an open space to the right of us, we're going to go there. If we're going down, if we're facing down, then the right-hand spot is on the left, actually. If we are going right, the right-hand side is down, and if we're going left, the right-hand side is up. So basically, we just need to account for this, because we can't actually see our guy going that way, so we have to kind of simulate this. It's quite confusing, but I'm just going to run through and do this all, and I think you'll understand. And if not, all you have to do is tinker around with it and you'll figure out what is going on. So basically we set the right hand position to the right, and if map right hand dot y and right hand dot x is not equal to 1, so if there's a spot to the right of us, our direction is going to be to the right. So there's an open spot, we'll take it. If there's not an open spot, then we're going to have to check if we can continue going straight. So if map guy position dot y minus 1 and guy position dot x is not equal to 1, so if we can't go right, then we're just going to try to go up. So we'll set our direction to up and we will return. Now if we can't do that, then we need to check if there's a spot to the left of us that we can go. So guy position dot x minus 1, if that is not equal to a wall, then the direction equals left and we will return. And last but not least, if we've come to a if we can't go right, if we can't go forward, if we can't go left, that means we've hit a dead end. So we're going to have to, actually we don't even need to do a check for this. We can just simply do direction equals down and return. I don't know if you could hear that. There was a really weird noise. Anyways, basically we're gonna have to do this with every single direction. So if we are going down, then the right hand position is to the left, like I said earlier, and we will try to go that way. So if that's not a wall, then we will go left. Else, if there's already some extra space in front of us, we will continue going down. If there is hold on, let me think. Oh yeah, if there's something to the left of us, which is actually to the right of us, then we go right. Else we will go up. So that's the down direction. Now we need to check the right. So if direction equals right, then the right hand position is actually down. So guy position dot y plus 1. So we'll try to go there to the right, and which is actually down. It's kind of confusing. I don't really know how to word this. I'm not sure, but we're just gonna go through it and hopefully it'll make sense. So if we can't do that, then we need to go right. If we can't do that, then we will go up. And if we can't do any of those things, then we will go left. And finally, if we are already going left, so if direction equals left, then the right hand side is going to be y minus 1. And if we can do that, we'll go up. Else we're going to go left. Else we will need to go down. So like so. And if none of those are true, we will go right. So this check move, it should work. So basically, I should probably explain this real quick, a little bit better. So, let's say we have, let me draw the map again real quick. So we have our map right here, which is a bunch of squares. And here is this is the character. And we are going up. So let me draw a little up arrow. So if we are going up, first of all, we need to check if the square to the right of us is open, and if it is, we'll go that way. If that's not true, we'll try to go up. If that's not true, we'll try to go left, and otherwise we'll try to go down. Now, what the confusing part is, if our direction is pointing down, then our right-hand side is to the left, right here. If we can't go there, then we'll go down. Otherwise, we'll go left. Otherwise, we'll go up. If we are going to the right, then our right-hand side is right here. So we'll try to go this way, this way, this way, this way. Otherwise, if we're going left, our right-hand side, just imagine I have a hand right here. It's right here at the top square. Otherwise, we'll go to the left square. Otherwise, down square. Otherwise, right square. So it's kind of confusing in how we're doing it, but it gets the job done. All you have to do is just mess around with it, and you'll figure it out. Now, we've done everything we need to, except one very important thing, which is the load map. So we need to make our load map function. And if I remember correctly, this takes a constant char file. Well, actually, the file path. And now we're going to need to make an input file stream called input. Make that file. And we need to include something real quick. What's it called? Fstream. So include fstream. Let's go back down. And okay, there we go. That fixed the problem. So when we first load our map, we are going to get the map width and the map height. But first of all, we need to check if input is open. So we need to make sure that the file exists. And we'll write, or not write, we'll set the map width, and we will set the map height, like so. And then we also need to loop through all of the tiles. So we are going to make double for loops. So for int j equals 0, j is less than map width, j++, and we need to make a vector real quick, and this is the row, and we're going to read into this temporary tile, and then so we'll be able to check if the tile is equal to 9, and the guy's position is equal to -1, and the guy's position dot y, position dot x, sorry, and the guy's position dot y is equal to -1, then we're going to set the guy's position. So guy position equals j, or guy position dot x equals j, and guy position dot y equals I. So we'll get the guy's position, else if the tile is equal to 8, then the goal's position is equal to j. I just can't spell anything correct today. And the goal's position dot y is equal to I, like so. And after that, we need to push back the tile, and outside of the loop, we need to push back the row to the map, like so. And when it's all done, map loaded equals true. So we've done quite a bit now, so we need to actually test this and see if it'll actually run, and hopefully we won't have to spend too much time debugging. So here we go. Sorry about that. There's an interruption, and apparently we have an issue here, so abort. And I believe I know what the issue is. We actually need to, we never called the load map function, so we're going to load level1.txt and see what happens. So let's run it, and hopefully this works. Oh, and there we go, our guy. So as you can see, it works. Let's make it so it doesn't close automatically. So we're gonna set quit game equal to false, and we will just say if not first, we'll say if not map solved. Then we'll do all of this like that, and let me indent it. Let's see if that worked. Let's see him go to work again. It takes a little while, and as you can see, there he goes. He makes his way, and he did it. Yay me. So, and apparently there it gets frozen. What would be causing that? Oh, right. Get rid of that. Oh, let's run it one more time. I think that fixed it. So now he will actually, yep, he goes through, he solves the maze. I did it, yay me, and we can exit. So that is all good. Let's try level 2, which is a bit bigger. So we'll be able to see him solve a bigger maze is what I'm getting at. So as you can see, there he goes, using the right hand rule correctly, going through, and there's the goal up there, and he made it. So yeah, there's the that's basically all there is to the maze solver. Yeah, so I will also have the source code available, so if you want to just get the source code and mess around with it, and maybe add your own things. Like maybe you could add a little menu that asks what map you want to load, and then it'll do the map, and then once the map is over, it could ask for another map to load, and you could go ahead and make more maps. As you can see, the first 2 lines are the width and height. Right now, the way it is, I believe it can only take perfectly square maps, so the width and height need to be equal. You can go ahead and try to fix up the program and make it better. Obviously, there's quite a few flaws with my map solver, so you can go ahead and update it and fix it however you want and make a better one. And if you make any fixes, go ahead and let me know, and I'd like to see what you've done, or you could like make a video response or something like that. But yeah, you just the width and height, and then you draw out the map using 1s, 0s, 9s, and 8s, and that is basically it. We basically have our little map solver. There he goes. So yeah, that about wraps it up. So if you have any questions or comments, go ahead and leave a comment or message me, and I will try to get back to you. But that's basically the map solver. Yeah, well, thank you for watching. Don't forget to like and subscribe, and I will see you sometime in the future, hopefully. Anyways, see ya.